Okay, so today we're still in section 2.3, but we are going to talk about the quotient rule. So how is the quotient rule the same and different from the product rule? If you remember the product rule, it was f prime g plus f g prime. The quotient rule is very similar, except it goes f prime g minus f g prime, and we have to divide by g squared. Your book explains why this works. They show you a little proof as to why it works. I don't really want to take the time to show why it works, but it is something that you're going to have to memorize. This prime is kind of hard to see, so you might even want to just go over top of that with your pen just to make sure you understand that it's going to be like this. So some people prefer to write it out in words, and we would say it's the derivative of the top times the bottom minus the top times the derivative of the bottom, all over that denominator squared. Okay? So we're going to do a couple of these for practice. You may want to write it out. This is a quotient. Okay? So it's not a product, it's a quotient. So we need to use a quotient rule. So this would be our f, and this would be our g. So I'm going to go ahead and write that out. My f is x squared minus 5. Our g is x. F prime, what's the derivative of x squared minus 5? 2x. And what's the derivative of x? Just 1. All right, so we have all this written out. You may want to write out the formula now off to the side. F prime g minus f g prime. Very much like the product rule, it's just the plus is a minus. Don't forget to divide by g squared. All right, so now applying this, I'm going to have f prime g minus f g prime all over g squared. So now I just have to simplify this. I'm going to have 2x squared minus x squared plus 5 all over x squared. And so that's going to give me x squared plus 5 all over x squared. Any questions about that? Now, this problem could have been done without the quotient rule. The other way it could have been done is you could have divided x squared by x and 5 by x. I'm just going to show you that real quick, kind of off to the side here, just to prove to you that all these kind of work together. So I'm going to go off to the side here. You don't need to write this down, just watch. If I do x squared divided by x, that's going to just give me x. 5 divided by x gives me 5 over x. So this is my original problem. Another name for the original problem. Writing it in a different way, I could write it like this. Now I'm going to take the derivative, not with the quotient rule anymore, because now I don't have a quotient. So the derivative of x is 1. The derivative here, negative 5 times negative 1, is positive 5x to the negative 2. That's 1 plus 5 over x squared. So why didn't I get the same answer that I got over here? Exactly. Get a common denominator. Multiply this by x squared over x squared. Now we have x squared times 1 plus 5 all over x squared. So you can do that, guys. If you want to not use the quotient rule, sometimes you can get away with not using the quotient rule. As long as this is a single value in the denominator, you can rewrite this so that you don't have to use the quotient rule. But the quotient rule will always work anytime you have some two values that are getting divided. All right, let's look at this next one now. This one, there's no way around it. We have to use the quotient rule because I can't split it up or do anything like that to rewrite it in a way that it's not a quotient. So let's write everything out. So f is always our numerator. That's s sine of t, rather. G is always the denominator. That's t cubed. F prime. What's the derivative of sine? Cosine. It's not negative, it's just cosine. And then the derivative of t cubed is 3t squared. And now it's just a matter of applying our formula. So the general derivative here is going to be f prime G, F prime G minus F G prime all over G squared. What's T cubed squared? T cubed times T cubed is T to the 6th, not 9th. See, look, guys, if I have T cubed squared, when I have a power to a power, the rule is that I multiply them. But understanding it a little bit better, T cubed squared is going to be T cubed times T cubed, which means this. Do you see why that's T to the 6th? All right, so this is going to be T to the 6th on the bottom. Now, what can I factor out of the numerator? Now remember, I can't factor out this T, and I can't factor out this T, but I can factor out of these two. So what can I factor out of those two? T squared, right? So I'm going to factor out a T squared. When I factor a T squared out of this one, I'm going to just be left with a T cosine T. When I factor T squared out of this one, I'm just left with a 3 sine T. Once again, remember, you can't do anything to change an angle. I'm not allowed to multiply it by any of this. These are two different values. These are two different factors. So now I have to divide by my T to the 6th. Now think about this. This is T times T. So on the top, I've got T times T, and on the bottom, I've got that T to the 6th. So what's that going to end up giving me? T to the what? T to the 4th on the bottom. So when I cancel these out, we've got T to the 4th on the bottom. And so this right here is going to be our final answer. Okay? Questions? All right. This will be the last one that we do for today. So on this one, let's write it out. We've got F is our numerator. That's x squared minus 3. G is our denominator. That's x minus 1. F prime is 2x. G prime is just 1. And on this one, we have to find the specific slope when c equals 3. So after we do all this, we're going to substitute in. So now to find my overall derivative, I'm going to do f prime g minus f g prime all over g squared. Now, one thing I want to point out here is that this will not be interchangeable. In other words, you cannot do these in a different order. It has to go f prime g minus f g prime. You could do g f prime minus g prime f, and that would be the same thing. But what I'm saying is you can't do this one first, or you're going to get the opposite sign of what you should. All right, so we've got this. Now, I don't really have to simplify this. If this were just something that I was not substituting in a number, I would want to simplify it. But because I'm substituting in a 3, f prime of 3, I'm just going to sub it in. So I'm going to have 2 times 3. 3 minus 1 is 2. 3 squared is 9. Minus 3 is 6. 3 minus 1 is 2. Squared is 4. Simplifying this, that's going to be 6 times 2. That's 12. Minus 6 is 6 over 4. And that's 3/2. Now, again, I just want to remind you, when I'm going to substitute in these numbers, this is something that I can check on the calculator. Watch what I can do. I can go to alpha, F1, and I can get my fractions, and I want to put in x squared minus 3 over x minus 1. I want to graph that. I don't know why that's there. Now let's try that again. I'm just going to use parentheses. You can also do that. Okay, so I do my zoom 6. We graph it. Here's the way it looks. I'm trying to find the slope at 3. So I go to second trace. And by the way, when I look at the slope at 3, I can see it's a positive slope. So that supports the answer that that's positive. But anyway, I'm going to go second trace, calculate, and I'm going to go down to dy dx. I want to know when x is 3, what's my slope? And it tells me it's 1.50001. This is an approximate answer here. The calculator actually gives you the approximate answer. This is the exact answer here. You could also, of course, say 1.5. But do not say 1.5000 whatever. Okay, any questions? All right. So today we're going to do the back of that worksheet.